Okay guys, here's another example of a torque equilibrium problem with a dog on a bridge. As I said before, with these kinds of problems they tend to be either high merit or low excellence. Now the first thing you've got to do here is draw, as it says here, draw the four forces acting on the plank, and you need to label the forces with symbols or words. And you want to label these forces in proportion to each other as well, so keep an idea of the weights involved here. So to start with, we've got the weight of the dog acting down here. So we're going to call that F dog, FD. We have the weight of the actual plank itself, and that acts the center of mass position of the plank, which will be the middle of the 10-meter plank. So we're going to have that acting down here. Now, just be aware that the plank is heavier than the dog, so I'm going to just put that a little bit longer in terms of the arrow. So FP. Let's put some numbers on here so we know that the mass of Billy the dog is 3.5 kilograms, and we know that the mass of the plank is 4 kilograms. So I'll put those numbers there as well. Now the other two forces that we have acting are the support forces, and that's A and B. Now I'm going to draw A this long and B a little bit shorter, because the I'm thinking that the dog, even though the dog is less mass than the plank itself, it's closer to support A, so it should be that way. If not, we can always tweak it at the end. So we have here FA, and over here we have FB. Okay, that's pretty much the first part of the problem done. We don't know FA or FB. Just to help us out a little bit down the track though, what we can do is actually work out what the forces are, specifically for FD and FP. So we know that F equals mg. So based on that, if we have a gravity equal to 10, to keep it nice and easy, that means that the force of the plank is going to be 4 times 10, so 40 newtons, and the force of the dog, 3.5 times 10, 35 newtons. Okay, moving on. So part B, by considering forces acting, talks about the end V, find support A, or end A, at the ends as shown. So it's asking us to consider torques about point B. Now typically the way this goes is that you've got to choose a pivot point, and if you want to find FA, you make FB the pivot point. If you want to work out what FB is, you make FA the pivot point. So because we're going to work out what the end A force is, we're going to make FB the pivot point, which you can see here by the red X. That means that where all the torques are going to act around that point there, and all of our distances have to be measured back to that point as well, which is very, very important. Okay, with problems like this, we always start with our two formulas. The first formula is the idea the torques clockwise have to be equal to the torques anti-clockwise if this object is going to be at equilibrium. And the second idea is that all the forces acting in the up direction have to be equal to all the forces in the down direction. So those are our two concepts that we need to start with and work our way through with. Alright, let's start with the torques. So I'm going to break this up into two parts. Torques clockwise. So what are the forces that are going to make this thing want to turn in a clockwise direction? Well, looking at it, there's only one force that will do that, and that's FA. So torque is a force times a distance. So we're going to have the force FA, and we're going to multiply that by the distance that FA is away from FB. And that distance there, looking at it, would be 7.5 meters. Just be careful when it comes to distances. It's not 10 because you've got a 0.5 overhang on the left hand side and you've got a 2 meter overhang on the right hand side, so it's 10 minus 2.5. Torques anti-clockwise. Well, there are actually two forces about that pivot which will make it turn in an anti-clockwise direction, and that is the FP and FD. So we break it up into two parts. We're going to have the force FP acting over a distance of, looking at that, that's actually 3 meters away from the support if we put the center of mass in the middle of the plank, and we want to add that to the dog, and the dog distance is 4.5 meters away from the red cross, the pivot point. Now we can probably add some numbers in here, so we're going to have, therefore, that's going to be equal to, now FP is 40 times 3 plus the dog, which is 35 times 4.5. Alrighty, at this point we can actually work out what that whole thing comes out to be. So calculator, we've got here, hold on a second, get into the right mode. We've got 40 times 3, and we're going to add that to 35 times 4.5. So 277.5 Newton meters. Okay, now we can come to the point where we take advantage of this equation right here, and that is that the torques clockwise must be equal to the torques anti-clockwise. This means that FA times 7.5 must be equal to 277.5. To work out FA, all we need to do is divide by 7.5 on both sides of our equation, and that is going to give us an answer of 37. Now, I realise that this problem doesn't ask for it. Technically, we've actually already solved the NCA problem. We've worked out FA, but what if you had to work out FB as well? Well, to work out FB, all we need to do is now look at this equation, that the forces up have to equal the forces down. Forces up, forces down. And that means the forces up are FA and FB. The forces down are F dog and F plank. So putting numbers in there, FA we've just worked out, 37. FB we don't know. FD, the dog was 35 newtons, and the plank was 40 newtons. So you can see therefore that to work out FB, all we're going to do is go 35 plus 40, take away the 37, and we end up with 38 newtons. Okay, by doing this I can see that FB is actually slightly bigger than FA, which means if I go back to here now, FB is slightly bigger than FA. Let's make a slight adjustment here. FB should be just a fraction longer. So we'll just make that adjustment there. FB being equal to 38 newtons and FA 37 newtons. There we go, another merit / excellence problem done. And they don't really get too much harder than that.